Hello and welcome. In this video, we'll talk about WebPagetest grades. WebPagetest grades evaluate the page data captured by the test and shows whether the page has passed or failed a certain goal. In this video, we'll look how the grades are evaluated and what we can do to improve them. In general, grades are evaluated first as a percentage. The numeric value is converted to a familiar letter grade on a standard academic scale. Anything that is above 90% is rated as A. Anything between 80 to 89% is rated as B. 70 to 79% rated as C. 60 to 69% rated as D. And 0 to 59% is rated as F. The grades are organized so that the most critical one appears first. This means you should first focus your efforts on optimizing things like connection reuse, gzipping, before moving on to other important but less impactful stuff like image compression and content delivery networks. Let's talk about the first byte time. The first byte time is the time at which the browser receives the first byte of the HTML content. Until this point, the only actions that are performed in the background are DNS lookup, initial TCP connections, and SSL negotiations if applicable. WebPagetest rates a test first byte time by looking at how long these phases take in aggregate and compares it against a target time. The closer to the target time, the better the rating. The grade automatically fails if the first byte time is greater than 7 round trip to the server. Let's evaluate the first byte time with an example. In this example, we'll consider 100 milliseconds for a DNS lookup, 150 milliseconds for the initial connection, and 500 milliseconds for the time to first byte. The target first byte time would be 3 times the initial connections. So in this case, the target first time byte would be 3 times of initial connections, that is 450 milliseconds. The observed first byte time is the sum of all the phases. So in this case, it would be 100 milliseconds for the DNS lookup, plus 1250 milliseconds for the initial connection, and 500 milliseconds for total time for first byte, which in return is 750 milliseconds. Let's understand how this is converted to a grade and number. The target first time byte would be 3 times the initial connection or 450 milliseconds. The observed first byte time, which is the sum of all the phases, is 750 milliseconds, which is 300 milliseconds slower than the target time. That would make the value 70, resulting in a grade C. WebPagetest does a good job of highlighting the opportunity for optimizing the first byte time. Let's talk about our next grade, Keep Alive enabled. Keep Alive measures the effectiveness of connection reuse. The purpose of this grade is to evaluate the extent to which requests are inefficiently reopening connection and resulting in performance degradation. WebPagetest checks the response header and ensures that there is a Keep Alive directive or information about reuse of the same socket. A connection must be made whenever communicating with a new host. A page with 2 resources from a single host should ideally make a connection for the first request and reuse the same connection again for the second request. A connection must be made whenever communicating with a new host. A page with 2 resources from a single host should ideally make a connection for the first resource and reuse the same connection again for the second resource. The first request is expected to negotiate a connection and the second of which is expected to communicate using an already open channel. Let's talk about how the grading is calculated. Take an example of a page load which interacts with 3 hosts. From host A, we make 1 request. For host B, we make 10 requests. And for host C, we make 7 requests. Host B is the only host that has Keep Alive enabled. In this case, the expected number of reuse connections can be expressed as the total number of requests less 1 initial connection per host. That would make 15 reuse connections. So host A is interacted only once, so that's 1 single connection. Host B is interacted 10 times, so it is 10 minus 1 initial connection results to 9 connections, and host C 7 requests minus 1 should be 6. But in this case, host C has not enabled keep alive, so it will still be 7 requests. So the expected connections, 15 connections, but since keep alive is enabled only on one host, we end up with 9 connections. The desired connections was 9, but we ended up with 15 connections, resulting in 60% trading. 60% of the requests could have shaved round trips worth of time simply by reusing the existing open connections. Let's discuss about our next grade, compress transfer. Compressing text-based resources over the network is a straightforward server-side configuration. When enabled, resources like HTML, JavaScript, and CSS file will be compressed or gzipped. This would result in smaller file size and quicker download. The formula to calculate compressed transfer is optimized resource size divided by actual resource size. To determine the optimized resource size, WebPagetest actually compresses each and every resource to find out if it is suitably smaller than the size of the resource as it was transferred. Suitably smaller in this case means that the resource is more than 10% smaller and more than 1400 bytes when compressed. The test is penalized proportionally to the number of bytes that could have been saved. Let's discuss about the next grade, compressed images. WebPagetest specifically evaluates JPEG images by optimizing them and measuring the difference. A test is penalized if it contains images that can be reduced in size by configuring them to a lower progressive and degrading visual quality to 85%. A formula to calculate this grade is optimized image size divided by actual image size. After compressing each image, its size is compared to the actual image without optimizations. The greater the difference, the lower the score. For example, if 1 MB of images could be compressed by 150 kilobytes, the optimized image size would be approximately 85% of the actual size, resulting in a grade B. Let's talk about the second type of images. JPEG images are of two types, baseline or progressive. Most images used on the web are baseline, which appears to load from top to bottom. Progressive JPEGs, on the other hand, show the entire image with low quality at first, then with gradually increasing quality. The advantage of progressive JPEG type is that the user perceives it to load more quickly, even if it's of a low quality. The formula to calculate the progressive JPEGs are progressive bytes by the total bytes. The web page test grading is based on a 10 kilobyte chunk of the image, each of which is checked for a new scan. Scans are gradually increase of quality. If the chunk contains a scan, all of 10 KB are considered to be progressive bytes. All of the test JPEGs are checked and the bytes are tailed to come up with the final value, which is then expressed as a letter grade. Let's talk about cache static content grade. Some static resources like images tend not to change often. Few pages may be repeatedly downloading these resources if they are not properly configured to stay in the browser cache. This grade checks the HTTP responses for resources that are determined to be static and evaluates them based on their lifetime. The formula is a little different from the previous grades, as this relies on a scoring system. The way it works is that a static resource response header are inspected for a cache lifetime value. This could come from a cache control, max age, or expires header. A static resource is given a score of 100 if its lifetime is greater than a week. If not, it can still be redeemed for 50 points if its lifetime is greater than an hour. Otherwise, it receives a score of 0. The score for all static resources are tallied and divided by the total number of static resources to get the percentage value and eventually a grade. The last grade to review is effective use of CDN. A content delivery network, or CDN, is a system of distributing resources to servers geographically closer to the user. One benefit of this is that the round trip time is faster to communicate over shorter distances. The formula is straightforward. The grading is calculated by the static resources served from a known CDN by the number of static resources altogether. WebPageTest keeps a log of known CDN providers. Each static resource is checked to see if its host server was one of such provider. The more resources served from a CDN, the better the value. This grade is unique. The passing grade for using a CDN effectively is to have at least 80% of static resources served from a CDN.